talk about cool stuff like graphics? Yeah, I thought, why else do you do computer programming? Well, do we have anybody doing the games thing in here? Games degree? Okay, yeah, all right. So it doesn't have to be graphics. I mean, you can still do text-based. All right. So in Python, in the language of Python, there's actually a bunch of different ways to do graphics. Okay. One is Tinker and TTK. Okay, which is a set of libraries that allows you to set up a window and do buttons in the window and basically do sort of a web front end. Okay? It's got a lot of stuff in it. It's got a ton of functionality and stuff like that. It's maybe the standard sort of way to do it. There's another interface, and the other interface is the one that we're going to be talking about today. It's much simpler. It's called, it's got a friendly name. It's called Turtle. Okay? So Turtle is a great, sort of quick graphical interface that's hooked into the Python system. All right? So what is Turtle graphics? So it turns out there's a language called Logo, created in 1967. Dang, that was a long time ago. And it was created originally to let little kids learn about computers. Back in '67, man, there was no such thing as a home computer. I mean, the only thing you really had was like a mainframe, okay? And there weren't that many of those floating around, okay? But Logo was created so that little kids could understand how computers work, and so they could actually draw things on the computer screen. That was the whole purpose behind it. Well, they've taken the whole concept and they've remembered it. Uses what's called turtle graphics. In the Logo language, you control a turtle. How simple is that? And you have the turtle go places. And when it goes places, it draws a line, right? And you have a pen. If the pen's up, you can go places and you leave no line. If the pen's down, guess what? You draw a line. And it really is that simple, okay? It's a great concept. It was designed to let little kids learn it, but hey, if little kids can learn it, you can learn it, right? All right, so let's see what we got going on here. So what's turtle in Python? So basically, let's say that you have a turtle. He always starts at the same spot when you start talking to the turtle. He's at location 0, 0 on one of those, you know, X, Y axis things. He's smack dab in the middle, right? You have to start off by executing the import turtle Python command. And what does that do? Import turtle reaches out to the Python interpreter and says, hey, I'm going to do some graphic stuff. Now, normally you don't have this going on, but this time you will. So find all those turtle commands that you have back in the warehouse and make them available to my program. So when you import turtle, what you're telling the Python interpreter is that I'm going to give you a bunch of turtle commands, so make sure that when I give them to you, you know what's going on. So it reaches into the warehouse, gets out all the turtle commands, and says, I'm ready for you. Hit me with what you got. Okay? Now what you could do then is give it the command turtle dot forward and then the number 15 in parentheses. Guess what's going to happen? Your little turtle is going to do what? And what direction is he going to move? Forward. What's the opposite of forward? Backward. Guess what? There's a backward command too, right? Okay, so boom, and he goes off and he draws a line that's 15 pixels long. Wow, this doesn't really seem like it's all that hard. No, it's not that hard. Okay? You can then give it the command turtle right 25. Okay? What it's going to do is he's going to rotate 25 degrees clockwise. So he'll point towards the bottom of the screen 25 degrees. Okay? And then if you tell him to walk off and draw some more, he'll draw another line and it'll have like a 25-degree angle from the line that you just had. Seeming pretty simple? I mean, it's designed to be pretty simple stuff, right? Okay. Tic-tac-toe! Yeah. Quick show of hands. Who's played tic-tac-toe before? Any hands not up? Okay. Have you? Okay, thank you. I appreciate it. Yeah, because I was waiting for you. I knew you were. Okay, no, I'm not going to be missed. Yeah, okay. All right, so what is tic-tac-toe? Tic-tac-toe consists of a couple lines, right? A couple more lines. And then what do we draw on the tic-tac-toe thing?
Circles and X's.
So we do circles and we do X's, right? Okay, I would like to draw exactly this image using turtle graphics. All right. Can't be that hard to do, right? I mean, we've got stuff, but we don't have like a lot of stuff. But let's do this together, shall we? All right. So, well, first off, we don't have any turtle commands, so I guess first we got to get some turtle commands. So let's talk about it. Whoosh! Here's a bunch of turtle commands. Turtle forward, we already talked about that, right? Go straight forward, and if the pen's down, draw a line, right? Turtle back. Thank you for not making it backward, because that's like less typing. Thank you very much. Turtle right, which is an angle, right? So you can make that turtle go off in an angle. Remember, the angle is clockwise. So 0's at the top, and you're going down, okay? Turtle left, angle goes the other way. Turtle go to. All right, so I'm here, and then magically I show up over here. Got it? Turtle set X. So I could be here, now just change my X coordinate to over here. Don't change the Y, just move my X. Same thing with set Y. And turtle home takes me right to 0, 0. No matter where I am, hit a turtle home and I go right back to 0, 0. So now you have all of these commands in your back pocket. Turtle heading, we talked about this. 0 means to go east. 90 means to go north. Stay with me. Where's 180?
West.
There you go. And 270 is what? That's all it is. Okay? We talked about the pen, right? So the pen determines whether or not you draw something. So pen down means put the dang pen down. Now if I move anywhere or go anywhere, I'm going to leave a line behind me. Pen up. Ta-da, guess what? I'm not going to do anything. I can move anywhere I want, and I won't leave a mark on the screen, right? And pen size determines how big of a pen I'm dealing with. Is it skinny? Is it fat? Is it whatever, right? Pen color. What color am I drawing in? Makes sense. And fill color. If I draw a circle or a square or something like that, should it be just empty, or should I fill it up with some particular color? And if so, this is the color that it should be filled up with. All right, tic-tac-toe. You ready to do this?
Yes.
All right. So when we do tic-tac-toe, and we're going to do it with turtle, where are we going to start? Where will we be on the screen when we start with turtle? 0, 0, right? So we're smack dab in the middle. We're sort of smack dab in the middle of our tic-tac-toe thing, right? All right, so we need to probably set up some sort of way we can talk about where we're at any point in time. Yes, sir?
So on Python 0, well, at least turtle specifically, 0, 0 is actually the center of the screen?
That is true. And actually an interesting distinction between that and Tinker and TTK is their zeros in the upper left-hand corner.
Yeah, that's what.
Right. But in Python, smack dab in the middle, okay? You write the library, you make the rules, okay? So we need sort of a reference system if we're going to do this. So I'm going to suggest what we do is we draw a box, okay? Now we need to figure out what kind of coordinates we're dealing with the box. So I'm going to say the upper left-hand corner is going to be minus 200x plus 200y. That make sense?
Yes.
I mean, this isn't rocket science, okay? So that means that over there is going to be plus plus. Down there is going to be what? Plus minus. And here will be minus minus. All right, so now we sort of have an orientation system as to how we're going to draw this whole thing. Okay, that's cool. So that's great, but I don't really care about the corners, do I? Not really. What I really care about is like this. So the top of the left-hand line is going to be what? Negative 100, 200? Okay. Which means that one's going to be plus 100, 200. We're good with that. Then if we go down here, negative 100, negative 200, and plus 100, minus 200. Okay? So once again, we just figured out where a couple points are. Now, of course, over here, we're going to have negative 200 plus 75, because that's what worked out nicely. And down here it's minus 75. And of course, over there we'll have the opposite. Plus 200 plus 75, plus 200 minus 75, boom. Now those 1, 2, 3, 4, 5, 6, 7, 8. Those 8 points are probably what we need to sort of pull this off, right? If we can tell the turtle to go in different places using those points, we should be able to draw the stuff that we need. That make sense? All right, so what we want to do is we want to draw this line, right? So we need some Python code. Gosh, Dr. Anderson, how nicely you've commented your code. Hint to class, when you write your code, you should comment it nice also, right? All right, so where's the very first thing that we do? Right, we got to tell the Python interpreter that we're going to be doing turtle stuff. So it goes off to the warehouse, it finds all those turtle commands we just talked about, right? And it brings them back and it drops them right there and says, okay, you want to reference any of these? Now I know what the heck you're going to be talking about. Okay, the very first thing we're going to do is configure turtle to draw thick red lines. So the first thing we do is turtle pen size is what? 10. It seems like a fairly thick line. Turtle color is what?
Red.
Because it'll show up well, right? Okay, now we're going to lift the pen and move to the top of the left vertical line. So first thing we do is turtle pen up, so we don't leave any marks. Because remember, we're at 0, 0, right? And then we do turtle go to that point. All right, we're good to go. Now we put the pen down, point south, and move to the bottom of the tic-tac-toe. Good. All right, so turtle pen down. So now anytime we move, we're going to leave a mark behind us, right? Set heading to 270. And what direction is 270 degrees? South. That is exactly correct. And we move forward, how many points? 400. Fantastic. Well, let's see how this all works, shall we? Does that look like lovely code? What do we got here? Import turtle, pen size, color. By the way, notice that Eric is colorizing some of my stuff, like my comments and some of my variables and stuff automatically for me. How cool is that? That's nice. Color is set to red, pen up, go to, pen down, set the heading, pen forward. Well, this is great, but let's go ahead and run it, man. That's what we're all about, right? Yay! Did that work out?
Yeah.
Do we have one line?
Yes.
I love it. It's a success story. All right. Now we want to draw the second vertical line. Hey, we got the first one down. Second one can't be that hard, right? So what do? Draw the second vertical line. Lift the pen up, right? Because otherwise we're going to have this whole big old smear line, right? We don't want this smear line. So we lift the pen up. Where do we go to? Top of the other line, right? Fantastic. Put the pen down. Exactly like we did before, right? Pen down. Set the heading to down. And we move forward how many points? Well, this can't be that hard to do. Let's see if we can do it. All right. Does it look like we have our code here? Draw the second vertical line, pen up, go to, pen down, set the heading, and probably, if we scroll down just a notch, there we go. All right. How cool is that? All right, we're getting there, right? Are we done? No. Oh, I got more work to do. Okay. Just when you think you have this stuff under control. All right. So the next thing we're going to do is what? Draw that top horizontal line, right? Let's just get the old hat at this one time. So what do? We lift the pen up. We don't want to ugly smear mark. Okay. Then we go to where? Left hand point, right? Okay. Put the pen down. Set the heading to what? What direction are we going to be moving in? East. Yes. And what value is east?
0.
0, right? So we set to 0, and then how far do we move? How many points? 400. Wow. This gets more and more exciting each time we do it. All right. Does it appear as though we have that code? Let's see. Draw the top horizontal line, pen up, go to, pen down, set the heading to east, and move forward. Okay, great. I think it's all there.
I thought you said we.
1, 2. Woo! See this happening.
I want to see a turtle draw the line.
Yeah. Actually, I will show you turtle in a little bit, but not yet. All right? All right, you got one more line to draw, right? Just the bottom line. So pen up, go to, pen down, set the heading, and move forward, right? So basically a repeat of exactly what we did, with the only real difference being where we start. Okay. That's pretty reasonable. Where?
The instructions.
What do I say? What?
You said go to -200, -100.
Well, that's not good because I copied my code. So you're saying my code's wrong, huh?
The code is right.
Code's right.
The
The instructions are wrong.
Oh. Okay, so this is what I have here. Pen up, go to, pen down. So let's give this a shot and then we'll go back and take a look and see if I've made an error. Ha! Like me making an error. I like that one. Yeah. All right. 1. Woo! Well, we got the tic-tac-toe grid, right?
Yeah.
We're getting close. Got a little bit more to do. All right. And who boldly said I made a mistake here? What, down here?
Up.
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 Right there. To the right.
No, you're right.
Yeah, there's one on it that says back to 110.
What did I have in my code? Did I have 75? Or
Everything was great.
Ah.
But yeah, there's also a slide that says that to go 110 or something. Yeah, the first slide.
Sounds like I did the code, copied the code, went back and changed the code. Apparently there's a QA issue going on here that we need to look into. Okay, well, congratulations, you're absolutely right. But it ran, right?
Yeah.
All right, well, that's it. What else? All right, circles. How do you do circles in Python? I mean, because it seems like we're sort of in the need of a circle, right? Well, what do we do? Okay, turtle circle. Well, we would expect that. Radius. How wide is the circle going to be? And this extent and steps stuff, which is just like weird. Okay. So radius is a number. Extent is a number. Steps is a number. I think steps is how round it is. If you do fewer, then it looks more chunky, and if you do more, then it's like more roundy like. That's the good stuff. Oh yeah, extent is, do you want to do a whole circle, do you want to do half a circle, do you want to do like a big chunk of pie, whatever you want to do, so you can extend that. Alright, circles. So now we know about circles. We should probably try and use a circle. Wherever shall we put our circle? In the middle. Fantastic. Can't be that hard to do, right? Well, what kind of code do we need? So we're going to lift up the pen, we're going to move to the circle, pen up, go to circle, pen down. Interesting enough, I forgot to do pen down when I was doing this. So I was watching on the screen, it would go, it would draw a circle, there was nothing on the screen. It was like white on white. And I'm like, well, what's up with that? And then eventually I realized, oh yeah, pen down. Okay. And then turtle circle with a diameter of 50. Alright. Let's give it a shot, see how it goes. Let's make sure we got the code there. Do we have the code? I don't know. Lift the pen up, go to, pen down, and draw a circle. All right, let's give it a shot. Woo! Getting there.
You're right.
All right, we're almost done, right? What do we got left to do?
X.
An X. Where are we going to put the X? Okay. And when we're making an X, what do we actually have to do to make an X? 2 lines, right? And they have to cross, right? In the upper left-hand corner. So we sort of know the coordinates that we're dealing with here. So it can't be that hard to do. So let's take a look and see what kind of this X code's going to look like. Oh my gosh, that looks like a lot of code. Really? Alright. So lift the pen and move to bottom left of upper left square, which would be like right here, right? Okay. Go to, okay. Point pen in the northeast direction and draw a line. Set heading to what?
45.
Alright, so this is 0. What, this is like 45?
Yeah.
Okay, so we're cool with that. And then we just do a go to. 120, negative 120, 180. So we're like just going there. And what happens when we go there? We're going to what? Draw a line? The answer is yeah. We'll draw a line. Okay? Cool. Alright. Then we lift the pen and move to the upper left of upper left square. So we're going to move right here. And then point pen in the northeast direction. Set heading 315. So I think that means we're pointing that direction. Actually, I think it's probably southeast. Does that make sense? So if 0's here, 315 is probably southeast. So that's a typo on my part. Sorry about that. And then go to negative 120.95, which is right there. With our pen down, we're going to draw a line. All right, let's give it a shot. All right, do we have all that code here? I think we do. Add an X. Lift the pen, move to the bottom, point the pen in the northeast, lift the pen, move to the upper left, point the pen in really the southeast direction, draw a line, rock and roll. Let's give it a shot. This is it. This is what we've been working for, guys. Our big tic-tac-toe payoff. Well. Woo! Is that what we were setting up to do?
Yeah.
All right.
We win.
This turtle stuff isn't so hard. Yes, sir.
What happens if you don't have the set heading and you just say go to? Wouldn't it still draw a diagonal line?
If I didn't put the pen down, if I did pen up and did a go to, I would just be in that location when I was done. Whatever the go to location, the coordinate was, right?
Okay.
However, if I have pen down, when I move from where I am to where I went to, it will draw a straight line between those two spots.
But like for the X,
Uh-huh.
can you take out the set heading? Because you're still going to go from one point to
The
another.
set heading would probably be left over from the last time I did it. Okay, so let's think about this for a moment. So the set heading was 45 degrees because I needed to tell it to go, oh, I understand what you're saying. You're exactly correct.
You don't
You are 100%
necessarily
correct.
need the set heading,
What it was, no,
still-
your point is well made. The set heading is not required. You're exactly correct. Clearly what was going on in my head, because of the way I did the other stuff, was I was anticipating drawing a distance, right? And in that case, the set heading would have been required. In the end, I said, screw that, I know where I want to end up, and so that's why I did the go-to. So you're exactly right. Did everyone get his point that he's talking about here? So I have this set heading, angle thing in there, which is lovely, but then immediately after that, I do a go-to. So I'm not actually drawing a distance, right? I'm not drawing a length of anything. I'm just going to a particular point. So the heading didn't really much matter one way.
What is it, still set at that?
Oh yeah.
Next.
Oh yeah. If I drew something else, if I moved off, if I did a distance, if I did a turtle forward, it would be done at a 45-degree angle from where I am currently.
So you could really just go to Vesta heading, like in that scenario, it's not like.
Right. And in this particular case, that's just the way I was thinking about it was just offsets as to where the endpoints were. But obviously, I was thinking originally about moving in the distance. Okay. Turtle extras, just a little extra sort of stuff like that. Turtle dot, just literally put the dot there. Okay, you can control the size of the dot, think of it as a small circle. Turtle stamp. This is what a turtle looks like, it turns out. The legs or whatever, okay? So you can put a turtle stamp anywhere. You can clear a stamp, chink chink. You can clear all the stamps, chink 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 chink. You can undo whatever you just did, okay? And you can control how fast the turtle moves. You make it go really fast or really slow or anything like that, depending on what you want to do. All right, once again, just more graphical control for you. Well, that's sort of cool.
The fastest is 0?
Yes. Fastest is 0, then fast is 10. Go figure. Not
Okay.
clear whatsoever. I have no idea why you do that. Okay? I suspect that that's probably historical. And one of the reasons it might be that way is because of the number of bits that they were using to store back in the day. So if you took a look at a binary representation of what's going on here, there may be some sort of linkage on it. I'm not going to say anything about whether or not that's true or not. I think that's probably just historical. Turtle state. So, you know, you're drawing all this stuff, stuff's going on. Every once in a while you might go, wow, where is that turtle? What did I set that as? So you can say turtle position, and it'll return an XY coordinate. You can move turtle towards someplace. You can get the X coordinate and the Y coordinate. You can get the heading, what's it currently set at, 45 degrees or 100 degrees, what have you. And you can say turtle distance from some particular location. So I know this location, where the heck is the turtle relative to this location? Once again, if you're creating a fantastic wonderful graphics program or a really cool game, all of these could be very, very useful, helpful things to have. Pen control, we already talked about pen down, pen up, pen size. And then the question, is the pen down or is the pen up? Right, and that's a logical return on that one. Turtle filling, so if I draw a circle or a square, if I would like it to fill up with a color, before I draw it, I can say begin fill, and then I can do like circle, and then I can say end fill, and it would turn it off. Let's see how that works in reality. Let's see what the code looks like. Whee! I think it's all with the O. Yeah. So we take a look where we draw the O. Pen up, go to, pen down, begin fill, do my circle, end fill. So what this should do is draw a circle and fill it up with a color. Okay?
What's the color?
I didn't specify, so it'll be the color of the circle. And what color is the circle?
Red.
There you go, exactly.
So
Woo!
if you wanted the circle to be a different color, you would just input the color code again?
Yeah, so there's actually a command that's like fill color. So you can set your fill color to a different color. So that means that the outside of it would be whatever color it is, and the inside would be blue or green or whatever you set to. That is exactly correct. Question?
Can you fill pieces? Like if you wanted to do half the circle?
You know, that's an interesting question. I'm not sure exactly what would happen with that. You know, I think you have to be able to, because when you're drawing a circle, you can specify how much of the circle you want to have done. So if I did like a half a circle, I think the fill command would just fill half of it. I haven't done it before, so I can't say. So I think you get a hemisphere or whatever you call half a circle, right? So it's a good question, and it's easy enough to find out, right? What did we cover today? We covered turtle graphics, drawing lines, drawing circles, filling shapes, and of course, making an extraordinarily difficult tic-tac-toe pattern. Good to go, all right? So now in your bag of tricks, you have turtle graphics, okay? Turtle graphics in Python are really simple, okay? They're not hard to do. It's a quick and easy way to get graphical output from Python. If you were creating like a web front end or something like that, you'd probably use the other package, okay? Which has a different set of commands. But if you just needed to do something quick and dirty, Turtle's the way to go because it's super easy to understand. What we're going to do next time, we'll be talking about the if statement, and we'll be talking about just a mess of relational operators. We're done. Thank you very much.